Hello! In this video we are going to review indeterminations and we will try to find techniques to resolve these indeterminations. Objectives. Okay, we will review the idea of limit, we will deal with this idea of limit, we will try to recognize or memorize when we are going to work or we are going to find indeterminations, and we will see how to deal with these indeterminations. Requirements, not so much, as usual. Some familiarity with algebra and calculus and some ability to perform with algebraic simplifications. Okay, let's see if we can understand everything in this slide. When are we going to deal with indeterminations? Here on this slide you can see 7 indeterminations. One is infinity minus infinity, 0 times infinity, 0 over 0, infinity over infinity, 0 power 0, infinity power 0, and 1 power infinity. Okay, be aware that sometimes you see this too easy. I mean, when many of my students tell me, okay, 1 power infinity is 1. Why is this an indetermination? Be careful. That means that the function on the base is approaching 1 and the exponent is tending to infinity. It's not 1 all the time, or you reach 1 first and then the exponent is growing and growing and growing, because if this is the case, the limit of course is going to be 1. The idea is that I don't know. We need to find out which one approaches first. The exponent tends to infinity faster or the base is approaching 1 faster. Okay? In order to do that, we need to apply several techniques. Okay? We are going to review the ideas of some indeterminations. We are not going to review every indetermination. So, and we will provide some techniques for example, 0 over 0 or infinity over infinity. Okay, let's start with indetermination 0 over 0. Okay, how are we going to do this, or how are we going to find or solve these indeterminations? That is not difficult. One option is the one you know, the one my students are always eager to apply. L'Hopital. They love L'Hopital. I don't know why. Okay. Okay. I know why. It's very useful. But there is not the only one technique to solve 0 over 0. How can we do that? How can we do that? Okay. This technique is applied only in specific situations. We will see in the next example. But we can multiply numerator and denominator by the conjugate of the numerator in the previous, in the following example you will see, and simplify the expression. So, depending on the function, this technique can work perfectly. Let's see. Let me show you. This is a general example in which we have the limit when h tends to 0 or approaches 0. On top, we have the square root of a plus h minus a square root of a divided by h. If we substitute directly h by 0, you eliminate this part. On the denominator you obtain 0, but on the numerator you got a square root of a minus a square root of a. That is 0 also. So you obtain the indetermination 0 over 0. What are we going to do? As explained in the previous slide, we are going to multiply by the conjugate of the numerator and denominator. What is the conjugate? Probably you are asking me. Okay, do you see here a negative in between these two terms? The conjugate is the same but with positive, okay? The same terms but positive. So I multiply by the same expression but with a positive sign in the middle on the numerator and denominator. Remember that on the denominator we got h before and it remains here. Okay, so if we multiply numerator in the two expressions, the two the two functions on the numerator, if we multiply this, you know that this is the square of the first one minus the square of the second one, because one is positive and the other is negative. I'm applying a function. Okay, you don't believe me? Perfect. Not bad. Then multiply this square root of a plus h times this square root of a plus h. So it's a square root of a square, so a plus h. Then you need to multiply this square root of a plus h times a square root of a minus a square root of a multiplied by this thing, exactly the same, both can cancel. And finally, minus a square root of a times square root of a, this is a square root a square, and then the square root disappears, and you got a at the end. Choose the method you want. Apply any mathematical property, or just multiply term by term, and then You simplify and obtain the same. As you can see on the numerator here, a and minus a can cancel. So the only thing left is h on the numerator. But remember, we got an h on the denominator also. So this h and this h disappears. They can simplify. So 1 on the numerator, and on the denominator I got the square root of a plus h plus the square root of a. Now let's substitute h by 0 again. When we change h by 0 here, I got 1 over a square root of a plus a square root of a, 2 times the square root of a. So we just resolve this indetermination and find the limit of this function. The technique is not difficult. Probably you think it's too long, but it's not difficult. It can be solved in 5 seconds. Another example, look at this one. In this case, you don't have a square root on the second term. It doesn't matter. It's exactly the same idea. You have a square root of t squared plus 9 on the denominator minus 3, on the numerator, sorry, divided by t squared. When we make t tend to 0, then if you substitute directly, you will have a square root of 9, that is 3, minus 3 on the numerator, so 0. And when you replace t by 0 on the denominator, 0 squared is 0. So we obtain an indetermination of 0 over 0. Again, do you want to apply any other rule? Fine, do it. You can choose which is the way you are going to solve this indetermination. I'm going to apply exactly the same technique we did before. We are going to multiply numerator and denominator by the conjugate of the numerator. And here you see it, okay? This is the numerator, and I multiply the numerator and the denominator by the conjugate of this one. Remember that the conjugate is formed just by changing this sign by the contrary. Okay, if this is positive, I would put negative here, but since this is negative, I have written positive on this part. Okay, then if you multiply, again, numerator, what you will obtain is t squared plus 9 minus 9. 9 and 9 disappear, so you got t squared on the numerator. The denominator, I just left it as it was at the beginning, so you can simplify t squared, and the only thing left is that function when t approaches 0. When you replace t by 0, what do we have? 1 over a square root of 9 plus 3. That means 3 plus 3, that is 6. 1 over 6, so this is the limit. As you can see, the technique is very simple, and it can be applied in situations like the one you see on the blackboard. Okay, what have we seen? We just reviewed the idea of limit, and we just solve indeterminations of the type 0 over 0 with a special technique. I think with this is enough. I know, guys, that you know many other rules. But today, remember this technique because it can be useful for you in the future. I hope you understand everything in this video, and thank you for your attention.